Welcome to the On-Premise IT Podcast, the only podcast that dares to be both on topic and on location. My name is Tom Hollingsworth, and I am a part of Gestalt IT, and each time we meet, we bring you the opinions and perspectives of a group of IT luminaries, experts in their field, to discuss a topic, a premise, if you will. Before we get into the topic of today's episode, I'd like to take a moment for everyone to introduce themselves so you know who they are before we get into the fun part, starting with Steve.
Hi, I'm Steve Puluka. I've been working in technology since the mid-'80s and recently retired as a service provider network architect with GQE Communications in Pittsburgh, Pennsylvania in the USA.
Hi there, everyone. This is Micheline Murphy. I'm a CSC at Worldwide Technology, where I provide kind of generalist, I guess, advice technology-wide. Prior to that, I was providing implementation services for folks who wanted to put Cisco ACI in their data center. And prior to that, I was a trial lawyer.
I'm Pete Welcher. I'm with Net Craftsman. I'm not sure I like being called a luminary. I feel like glowing a candle in a bag, but I'm a 25-year CCIE. I've recently dropped down my hours, and that means I get to play with Network Field Day and startup companies and blogging.
All right, well, thank you all for joining us today. Let's jump into the premise for this episode. It seems like we've been wrestling with network monitoring and management for a number of years. And as long as we've been wrestling with it, we've been wondering what to call it, because are we really monitoring things? Are we really paying attention to what's going on? And in modern times, with the introduction of things like telemetry and data analytics and a bunch of other interesting technologies, now we talk about observability as a kind of a catch-all term for everything we want to do. But no matter what we call it, we're still focused on making sure that we know what's going on in our environment and what we need to do to fix problems before they become huge issues. But we don't always know exactly what's going on, and we don't always exactly know how to fix it. And part of that problem is that we're still sifting through an enormous amount of data. Unfortunately, it looks like observability needs to be smarter. So when we started discussing this episode, we kind of threw around some ideas and talked about some of the examples that we've seen. So has anybody run into an issue where they feel like observability hasn't given them the information that they've been looking for?
Yeah, I thought I'd like to talk to that exact point because I had a hand in suggesting this topic. And what I've experienced recently is 2 customer outages. One turned out to be an obscure form of DDoS where the firewall wasn't well instrumented. So you couldn't see that there were resources being consumed, let alone which resources. So you have to have the lesson learned there, I think, is that the vendors have to be more forthright about critical measures and make that data externally available. The second one, it's interesting that Micheline said ACI because we have a customer who filled up TCAM in their ACI. And the Cisco account rep, who was very senior, has been hustling. I won't name his name. He said he spent about a week in his lab, and he finally came up with some way to correlate access list rules, in effect, policies, contracts, with growth in TCAM, because that's kind of what the customer needs is, okay, if I change this rule, does it improve things? And so that's another case where that's pretty critical. If you strap a huge VMware cluster onto a couple links on one pair of border leaves ACI, that's something you may run into. And if you can't even see what's going on and kind of poke around and figure out how to fix it, you're kind of roadblocked.
Well, I think, Peter, that really kind of brings up kind of the complexity of observability, because it's one thing to know what's going on. I mean, and, just from your example, the ACI will, if you know where to click, finding out what TCAM is being consumed where in your ACI fabric is a reasonably easy prospect. But, there's that next step to understanding, well, this switch is like 75% TCAM utilization. What does that mean for, my packets? And what does that mean for the overall experience of the you know, of the VMs that are utilizing the fabric or what have you. So there's, I think, you know, when I think about how Tom has kind of cast the problem of observability, is it really all boils down to what's the ability of the networking team to be able to consume the information that's coming at it. And you know, there's first of all the big question of just sheer volume and trying to parse down that sheer volume, but there's also, you know, the ability to say, well, here's the root cause, you know, and be able to actually just technically understand what's going on. So, you know, I think, you know, it's complicated, I think, and I think it's different from team to team. So I think it ends up being a really particularized conversation that you have, because one good observability for one team might not be good observability for another team.
You have this getting the data, and then you addressed sheer volume. And what I expect is there's sort of a trend in computing. As servers became cheaper, we could put more VMs on them, and we got denser and denser. And I think the same thing is likely to happen with observability, that we'll be getting more and more data. And the example I'm going to pick right now is Cisco Thousand Eyes, or many of its counterparts, where you can turn it on, and if you can afford it, you can do a reasonable amount of polling, although you want to be smart about it. But I see the next logical step as being something that automates that. So if you have a fabric, all of your leaf nodes will hit the core nodes, and then the core nodes will hit the wide area router. The wide area router will hit the firewall, or maybe go through the firewall to the cloud. And so you will be maybe able to automatically provision a smart mesh of measurements, but that's going to up the scale of the measurements by a factor of 10 or more. How do we cope with that? And so Cisco's now talking about insights, and the other vendors have AI, but is it real?
Well, I think the problem really isn't new. I mean, we've been overwhelmed with alerts for decades. You know, it all boils down to correlation. You know, as you mentioned, you know, what you really care about is the root cause. Observability really doesn't change that fundamental problem that we've had all along. And I think the real focus on observability is to try to make that correlation type work happen and march the effect of it up more towards the experience side of the end user. So we've had this naming change going on in the industry, you know, this push towards experience. And I think observability is part of that nomenclature change, where we're not just monitoring and alerting, but we're trying to correlate these events that happen down to the root cause so that it actually makes a difference in the experience of the applications and the users that are using the applications, rather than just, you know, making sure that we don't cross thresholds for the sake of not crossing thresholds, because quite frankly, some thresholds don't affect the experience. So, you know, who gives a damn?
One of the things that Thousand Eyes and the other guys can now do is they open up the door to something. As a reformed mathematician, I've got to call it bisection search. Namely, you start some polling, and if you suspect, say, a firewall, you pull from the inside, you pull from the outside out to the internet. And so you can say, oh, okay, on the outside edge, things were good. On the inside edge, things were bad. The problem's in between those 2 points in my network. And so that's a dirt simple technique that sort of moderate volumes of polling and observability will get you. Is it, where's it good, where's it bad kind of out? And that trumps AI to some extent, because it's dirt simple and it works.
Right. I was going to ask Peter if that was the sort of mechanism that you could automate, because just because it's a, you know, a tried and true method doesn't necessarily mean that network teams have the human intelligence to be able to implement this tried and true method. And so, you know, we talk a little bit about AI as being kind of the, you know, the end all be all, and you know, somebody for one always wants to welcome their, you know, AI overlords, but you know, there has to be some way that at the end of it all, that the whoever's teaching the AI has, you know, the smarts of the engineer who would actually troubleshoot the network. So, you know, it's great to have the tools, but can you actually get them in place and have it be meaningful for the human team?
Yeah, that side of the equation can be difficult because, you know, most of the techniques that are most accurate require supervised training information to work. So they're, you know, like most things in the observability space are really just machine learning, not full on AI. And most of the most effective ones of those, you know, work on labeled data and learning in the sense that you're talking about there, where you would train an engineer to notice these things, correlate them together, and know that it means it's that problem. And that's pretty straightforward for machine learning to handle. It's the unknown cases and the unsupervised stuff that's much more difficult for the machine learning to kick in and do something reasonable on, and where the, you know, the real nuts and bolts of the work today needs to be concentrated.
One of the challenges that I see in the field is the AI sounds great, may just be machine learning, and I wish that people would be clear about which of the two it is. The vendors aren't exactly revealing what exactly they're doing. So I've been calling it AI washing, for lack of a better term. But, oh, we have great AI, trust us, we'll magically solve their problems. Or maybe not so magically, but could you please tell me what 50 things you're going to do for me? And, you know, what measurements? And like, I'm impressed with certain vendors, and I think maybe Wi-Fi is pretty easy, or WAN is pretty easy, because you can measure things like drop rate and discard rate and error rate and stuff like that. And if it gets outside 2 sigmas or something, talking statistics there, 2 standard deviations, then maybe you'll alert, or maybe you have a history and correlate it with day of the week, time of the day, and type stuff. That's getting a little closer to AI turf. I don't know where I'm going with this ramble, but
Well, actually,
yeah.
let me jump in, because this is an interesting point that we all bring up, because depending on how far back you go, you think that network monitoring and observability, quotey fingers, is SNMP. And anybody out there who just wanted to punch me in the face, you're an old school networking person like me. But one of the problems that we actually run into is the fact that in order to have a good learning model, as Steve brought up, that has structured learning and that understands these things, you need to load all of the data into a data lake, essentially. And there are a lot of companies out there that are talking about the size of the data lake that they're pulling this information from. But in order to get that data up there, you have to send it into the cloud, right? Well, how do you do that? Because we have some people who say, send everything, you know, forget about bandwidth costs. We don't care. Just put it all up there. We'll munge through it. We'll tell you when things don't look right. Other companies are saying, no, 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 no. We need to use edge computing platforms in order to do as much pre-processing on the data as we can on the edge before sending the critical stuff back to the data lake to do that munging, so that we're not overloading the bandwidth. And oh, by the way, that means you need an appliance that we just happen to sell. So we're kind of caught between these two polar opposites, if you will. Do we do as much processing we can on site that requires more investment up front, and it may not give us the answers we want? Or do we send it all to the cloud to be munged through magical ML algorithms in a huge data lake, and pay for the costs of that and hope that we get the answer that we're looking for? Well, is there a middle ground that we can get to?
Well, I think Peter hit sort of the nail on the head here. Is one of the things we have to do as engineers is hold vendors' feet to the fire and make them say exactly what they're doing under the hood. What I really dislike about the AI label is that it hides which technique is being used, as Peter mentioned, under the hood. You know, I mentioned there's supervised, unsupervised learning, and Peter brought up that there's statistical analysis that's going on. So what we really need to know to make those determinations you're talking about, you know, is it best to do edge or full cloud, or a combination of both, is to understand what is the model, how is the model trained, can the model be trained in the cloud and deployed to the edge to work? But in order to make those reasonable decisions as a technologist, you have to tell me how your model works, under the hood, and how it was trained. And therefore I can determine whether or not the data I'm about to trust to your model is similar enough that it does make sense that it's going to work in my environment the way I need it to.
Kind of a sidetrack, but I just saw something about quantum computing and training data models. And it basically said you could drastically reduce the amount of data you feed in, if I remember correctly. And I ended up thinking, does this mean that all your fancy AI model is doing is basically replicating 10 data points? In other words, feeding it millions of samples is actually baloney, because all you're doing is emphasizing the same thing over and over again, put in lay speak.
And that gets into other problems itself, because we're all familiar with horrible human-made decisions that AI replicates because the data that they were fed it is of poor quality, or the wrong conclusions came out of the data. So I think what Tom's kind of getting to about the are we going to do edge versus cloud is a separate issue from what Scott and Peter are talking about, which is, what is the model actually modeling? How does it actually work? And I think, for savvy networking teams, they're going to be asking both questions. And so I think that, it's great to be able to provide networking teams with options to be able to say, well, you've got vendor A that their model works like this, and they support it in the cloud, and they run vendor B that their model works like Y, and they support cloud and on-premise. So just being able to parse through the different providers and vendors and be able to categorize their offerings in that aspect is sometimes really a chore, because as Peter and Steve both pointed out already, there's not a whole lot of clarity as to what the vendors are actually selling. It's sometimes I kind of feel like they're selling like pay no attention to the man behind the curtain. So
I want to start with what problems does your tool actually find? I don't care how it does it, just what is it doing for me?
Yeah.
And then maybe I care about, okay, it's AI or ML or statistical analysis or whatever. Why should I trust it? Kind of give me an idea, a flavor of what it's going to do and what it's going to miss.
That's part of the thing you have to start with is, what is this system designed to observe and define? Is that a problem I have? So starting there,
Right.
once it is a problem I have, then I want to know how you're doing it, and so that I know whether or not the data that I have that's going to be fed into the observability system is going to be properly interpreted and running through this. And I also want to amplify the idea of, you got to make sure that bad assumptions aren't being taught into this thing too. I mean, we have many examples over the years where I know the IEEE highlighted something that was done in the 80s in doing algorithms for Harvard admissions, where they literally pre-programmed in biases against poor people and people of color into the admission process computer algorithm, because that's what the human admissions people told them was correct and proper to do. You have to ask what's going into this algorithm, because you could be getting these totally nonsensical and unintended consequences out of it, unless you're open and honest in where you're getting your information from.
And I think it's also important to distinguish, because there are tools out there that are available right now. They'll take your data and they'll process your data, but there are also tools out there that take some kind of, anonymized pool of data that is quote unquote similar. And then now you can use the model's pre-built. Look at all of this, this great work we've done for you. Just plug in, and our wizard will will magically manage your network, go have happy hour. And so, there's a huge range of things out there, to get AI involved. And, I think sometimes it's somebody on a C-level heard about this great AI tool, and now they've got their a bee in their bonnet to, let's get this latest and greatest tool going in our network, and it'll make everybody's life so much easier. And it's just really critical for, I guess, the buyer to be really aware of what it is that they're looking at and what it is that they need and what it is, that will work for them.
What I just realized that one vendor's product, I'm not going to name, actually built end user training into its product. Although this is more in the tool proposes it in action, and you can say, "I trust, go do it," but you can also say, "And in the future, just do this automatically." And so that feedback is actually an interesting way to leverage crowdsourcing to improve your product.
Yeah, and that's why it's important that you understand how the product is working too. You mentioned pre-trained models. So that's generally going to be a supervised machine learning thing. So it's critical that you understand whether or not your data, your systems, is similar enough to the training data that it was run in the model. Then you can trust it. Then you can run it. However, it's different if, say, the model is built on a statistical model that's saying, I'm going to react to things based on them being a statistical anomaly outside, the standard deviation 1.5 or something of that nature. Well, that works great if you have a regular business. But if you have things that are going to be bursty and out of things, then maybe standard deviation statistical models are not the kind of monitoring that you want to have in place in your observability solution. So it's important that you know what your data looks like, and it's important you know how the observability solution is implementing their things so that you get the correct match and a working solution.
And I think, Peter, sometimes, as customers go to take a look at, and networking teams go to take a look at, I want to bring in an AI tool in, it's just like any new technology. Sometimes you just don't even know what questions you need to ask in order to be able to make sense of what's out there. And so, one of the things that you pointed out is being able to understand what's in your own data, in order to be able to make an intelligent decision about, somebody else's pool of data. That understanding in and of itself may be something that's just difficult for, some networking teams just to take on their own. And so that seems like to me, that would be a barrier to entry for some folks into, bringing on AI or ML tools.
Well, the other big gotcha there in this sharing of the data is you have to be concerned with privacy as well then too. As service providers, we're under certain regulations involving, customer data, customer proprietary network information, and, companies like DQE have SOC that we're responsible for too. So we have to be really conscious when we're sending data to a third-party vendor like that it's stuff that's allowed by the regulations and the certifications that we're operating under, in addition to the problems of whether or not the damn thing's going to work.
There's a flip side to it that I just realized as well. Third party, if you've outsourced your firewalling or some of your antivirus, I'm thinking Umbrella, but other products that are similar, where your your connection goes through the cloud in effect. How do you detect problems with the vendor's software?
We've debated a lot of the things that are impacting the ability for our observability systems to get smarter. What is the one thing in your mind that you can think of that engineers and practitioners can do to help increase the intelligence of an observability solution? What can we do to make an impact on this?
one of the things, like the first thing I always think of is get yourself educated. If you're thinking about getting AI tools, in your environment, or, that's something that you're interested in, it's great to, get a little bit of education under your belt, make yourself dangerous, and then start asking the same kinds of questions that the three of us have been chucking around. So, things like, what's in the data that you're using? Are you using a pre-built model? Are you using a model that you're going to create just out of my data? Who's got that data? Where did it come from? On and on and on. And being able to understand that, as well as things like, what am I really looking for in a tool? What do I really need the tool to do? Basic things like, what's too much, what's too little, being able to understand what your own tolerance is for observability, because, it swings in a pendulum. We started out, and, when everybody was at the CLI, there was no observability. There's no monitoring. Now we're at the point where, something goes wrong and you get, 900 faults, and, you don't know which one to pay attention to. And that's where we start talking about, well, let's bring some AI into this to help weed this out for us and thin this a little bit. So, being able to understand all of those things, and sometimes that's all of that, and ingesting all of that and being able to wrap your brain around all of that is a heavy lift.
Maybe think about how it could be better and communicate with your vendor.
There's two things here. I want to amplify the education part. As we move to AI observability, most of the major universities like MIT, they are into a thing called OpenCourseWare. Take a basic machine learning or AI class, get to know what the types of models are, what the concepts are, and what the math behind this stuff is, so that you have a foundation to make your own things. The second thing I think is critical is to take a look at the problems you are manually solving today. Document the decision trees you're going to and the data you're using to solve those problems. Because that's how a machine learning model is built. And so once you know the types of problems you're having and how you solve them, then you can take that along with understanding then how AI and machine learning works and evaluate, is the vendor's AI solution compatible with what you know works in your environment?
A word about maybe why AI is needed, which is that I think there's been a shift recently. We have some, with S&P and other means, we now have up-down monitoring, and we can detect failures, or most failures. If the thing we can't detect is kind of gray failures and brownouts. Talk about different colored problems. But situations where something's not performing up to snuff is now, I think, where a lot of our customers are. And it's kind of harder to find what's the cause, because it's not just up or down. It's something is eating my packets somewhere in the middle.
Yeah. Or just intermittent failures even.
Yeah. Why is it going? Well, we have a customer where their remote access VPN would go down every hour on the hour.
As you can tell, there are a lot of things that are involved in modern observability solutions. It's not just as simple as remembering an OID or making sure that you're using the right SNMP strings anymore. There's a lot of processing that has to happen, both pre-processing and post-processing. You need to know where your data is going. You need to know how it's being used. And quite honestly, you need to educate yourself on the entire process. Just like any complex system, the more you understand about it, the more you can rely on the data that you're getting back from it. Garbage in, garbage out. If you are coming at this from an intelligent perspective, and you know what you need to look at, you know what you need to look for, and you know what would look like something outside of that, then you'll have a better idea of how to get good data, good information out of the system, rather than just relying on it to hopefully one day tell you something doesn't look right here. That will just about do it for this episode of the On-Premise IT Podcast. Thank you all very much for tuning in. You can always find the latest episode on our website at gestaltit.com/podcast. You can also subscribe to us in your favorite podcasting application of choice. You can also subscribe in iTunes. And if you do, wherever you happen to listen to us, make sure you leave us a rating and a review. Those things really help people figure out that we are all about enterprise IT tech and a premise, not just an hour-long intellectual discussion about all kinds of random things. We should be back with you in just about 2 weeks with another great episode. But until then, thanks for tuning in, and we hope that you'll stick to the premise.